Welcome to BTEC Revision. In today's lesson, we're looking at immersed bodies. By the end, we should be able to calculate the mass or density of an object using Archimedes' principle. Archimedes' principle states that a body totally or partially submerged in a fluid displaces a volume of fluid that weighs the same as the apparent loss in weight of the body. What this means is that if we place an object inside a beaker full of water, the amount of water that spills out is going to be equal to the volume of that object. Let's consider an object that is suspended by a string and fully submerged in a beaker of water, as you can see in this diagram. What are the forces acting on this object? Well, we'll have the force due to gravity, Fg, pulling this object down, and there will also be an upthrust force pushing the ball up, and there will be a force due to tension on the string. If we consider this object to be in equilibrium, then we can say that the force due to the tension plus the force due to the upthrust is going to be equal to the force due to gravity. And we can calculate the forces using our equation for hydrostatic thrust. And if you remember that, we have F equals rho G A of X. And for the weight, in this case, F of G, that's going to be the density of that object. Let's label that as the ball, B. So the density of the ball, gravity is constant, so that doesn't make a difference, times the area of the ball times the position of the ball, B. And we can do something similar for the upthrust, and that's due to the force acting on the ball because of the water, and that's equal to rho upthrust of the water. We'll label that as W, and G is a constant, A, W, and X, W. And the area times the height is simply equal to the volume, so we can rewrite this as rho of the water times G times the volume of the water, and for the bottom ball, we can write rho of the ball times G times the volume of the ball. Now let's look at a partially submerged body. Here we have a ball, and it's not fully submerged, it is floating. And it's not going up or down, so we can say that the forces are balanced. So the force due to gravity is equal to the force due to the upthrust. And we know these values, okay, from before. We have the force upthrust is equal to rho of the water times G and times the volume of the water, and F of G, so the weight of the ball, is equal to the density of the ball times gravity times the volume of the ball. Since these forces are equal, we can equate these two equations to give us rho water, G volume water, equals rho ball, G volume of the ball. And you can see the G values cancel out on both sides, and we're left with the equation rho W, VW equals rho ball, V ball. And this is a very important relationship that we can use in order to work out the density or volumes of any object partially submerged. Now, let's look at an example. A cube with length 10 centimeters is floating in a beaker. Calculate the density of the cube given the cube is partially submerged by 5 centimeters and the density of water is 1000 kilograms per meter cube. Firstly, we can start by writing down the parameters. We have the volume of the cube, which is equal to 10 times 10 times 10 centimeters cubed. So that's 1,000. The next thing we need to know is the density of the water, which is 1,000. Okay. So we have two values here. And if you remember from Archimedes' principle, the amount of fluid that has been displaced is going to be the volume, and we can calculate that using the amount of the shape, in this case a cube, that is submerged in the water. So the volume of the water is going to be equal to, and it says here it's submerged by 5 centimeters, so that's going to be 10 times 10 times 5 centimeters cubed, which gives us a value of 500 centimeters cubed. Now we can write down our equation. So the density of the water times the volume of water equals the density of the cube times the volume of the cube that has been displaced. So rearranging that for the density of cube gives us density of the water times volume of the water divided by volume of the cube. Now we can plug in our values. So the density of the water is 1,000. The volume of the water is 500. And the volume of the cube is 1,000. And that's going to give us a value of 500 for the density of the cube. Now pause the video here and attempt this exam question. 1 in 12 slices makes a pizza which has a height of 2 centimeters, radius 10 centimeters, and is floating in a river. Calculate the density of the slice, given that the slice is partially submerged by 1 centimeter, and the density of water is 1,000 kilograms per meter cubed. The first thing we can note is that we need to calculate the area of this pizza, and this has the shape of a sector. So we will need to work out the angle, and we can see we have 1 in 12 slices. So if we take a circle, and we know the circle has a angle of 2 pi radians, and if we take 1/12 of that, we can divide the angle by 12, and that will give us a value of pi over 6. So we know the angle is pi over 6. And next, we can work out the area. And if you remember our lessons in mathematical techniques, the area of a sector is a half r squared theta, where that is measured in radians. So we can plug in our values now. The radius is 10 centimeters, so that's 0.1 meters squared times angle pi over 6. So the area is equal to, and that gives us a value of 2.61 times 10 to the power of minus 3 meters squared. Now we can work out the volume of pizza, which is equal to the area of the pizza times the height of the pizza. And we worked out the area already, which is 2.61 times 10 to the power of minus 3. And the height is 2 centimeters, so that's 2 times 10 to the power of minus 2. And calculating that would give us a value of 5.24 times 10 to the power of minus 5 meters cubed. Looking at our equation here, to work out the density of the pizza, we would need the density of the water, which we have, and that's 1000, and the volume of the water, so we need to calculate that, the volume of the pizza, which we have just calculated. So let's calculate the water volume. Volume of the water is going to be equal to the area, and that's going to be the area of the pizza, which is 2.61 times 10 to the power of minus 3. But it is half the height because it says it is partially submerged by 1 centimeter. So we'll have to times this by 1, and that's times 10 to the power of minus 2. And calculating this would give us a value of 2.61 and 8 times 10 to the power of minus 5 meters cubed. Now we have all three unknowns to work out the fourth unknown. So we can plug all of these into our equation. So that would be the density of the water, 1000, times the volume of the water, which is this one. So that's 2.618 times 10 to the power of minus 5 divided by 5.24 times 10 to the power of minus 5. And calculating this would give us a value of 500 kilograms per meter cubed. So it's dense pizza. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com. See you next lesson.